Hi everyone, welcome back to the AI language. Today we are going to build an A2A server agent using Docker, and we're going to deploy it locally and also on Google's cloud platform, which is GCP. And if you're exploring Google's agent to agent protocol and you want to run your own agents in a Docker container and deploy them to the cloud, this video is for you. What we'll do is we'll walk through the setup, Dockerization and testing it using a simple curl request for one of the agents that we have previously built. Please don't forget to like this video and subscribe to the channel if you enjoy working with A2A and MCP and building AI agents. So before I begin, let me give you a quick preview of what we are going to build today. We have already built several A2A examples with A2A agents and A2A agents working in tandem with MCP. We also added a vision agent and we worked with the Python A2A SDK, which is all available on the GitHub repository that you can access. Now what we are going to do is we are going to take a vision agent that we had built previously and we are going to build version 6, which is a Docker version of the same vision agent that we can then deploy locally and also push to Google's cloud. When you check out the code, you'll see all the versions over here like so, and we're going to focus on version 6, which is what is new. Inside version 6, you'll see just one agent and all the other support files. So you have the agent, which is the vision agent over here inside the agents folder. Then you have different models and you have the server code which the vision agent uses. There is no other code over here because we just want to work with the agent. So we don't have a command line app or we don't have a A2A client like we had before. You can see that there are some sample AI images over here. For example, you have a computer image over here, and what the vision agent can do is that it can take this image and a user query and then answer that query based on what was requested and the image that was provided. This image can be provided as a local path or also as a URL. That is what the vision agent does, and our aim is to containerize this using Docker and then push it to Google Cloud and get a URL for this and be able to run this over the internet on Google's cloud platform rather than just locally on our own computer. To do this, we are going to use a Dockerfile like so. We're not going to change anything in the vision agent code, so you can actually look at our previous video which works with the vision agent, which was covered in version 4.01 over here, and how this agent works and how this is built. But today we're going to focus on containerizing this agent. So why use Docker with A2A agents? Docker basically provides a clean, portable and consistent environment that ensures your agent behaves the same way on any machine or cloud platform. Instead of worrying about system dependencies, Python versions or package conflicts, Docker wraps your entire agent, including its code, libraries and tools, into a single image. This is done through this Dockerfile, and this makes it easy to deploy your A2A agent anywhere, whether it's on your local machine, a collaborator system or a cloud service like Google Cloud Run. It also improves the security and reproducibility, which is especially important when you're running multiple agents or sharing them publicly. So that's why it's important that we understand how to use Docker to containerize your A2A agents and servers. So let's walk through the Docker file now. We're inside the version 6 Docker Vision Agent folder inside our A2A samples directory, and we have selected the Docker file over here. The Docker file starts with Python 3.11 Slim. So this is the base image that we are going to use. We use bash as the default shell, so we can use commands like source and all the other bash features. Then we're going to set our working directory as /app. So this is what is set as the working directory inside the container. And now all commands will run from this directory. Now we install the essential system dependencies. We install curl so that we can later use it to download UV. And no install recommends keeps the image size smaller by skipping optional packages. Then we download and install UV from the official Astral script. Then we add debug print statements to verify where UV is installed so that we can see that in case we want to debug. Then we temporarily add UV to the path for this run step. And now we verify that UV is working by printing the version of that. Finally, we clean up the cache to reduce the image size. Next, we add UV to the path permanently for all future Docker steps. So this ensures that the command UV is found even without specifying this full path over here. Now we copy all the files from our local directory over here where Docker build runs into the containers app directory, which we have set earlier via work directory. Then we create and activate a virtual environment inside the Docker container. So these are the commands that we have been running earlier in the previous versions on our local machine, but now we're going to run them inside the Docker container. So uvvenv will initialize the .venv folder, then source.venv/bin/activate will activate this virtual environment. And finally, UV sync all groups and UV sync upgrade will install the dependencies and ensure that these are the latest compatible versions that are installed. And this will be done from the pry-project.toml file over here. Then we'll expose the port 10,003 so that Docker knows which port the container serves traffic on. Finally, we'll run the server when the container starts. So UV run is what executes the command inside the activated virtual environment. Python 3-m agents.vision agents runs the agent/vision agent.py module, and then the host specified over here binds to all network interfaces which is needed for Docker and GCP, and the port 10,003 runs the service on port 10,003. So this is a pretty simple Docker file, and what it does is that it encapsulates all the steps that we have been following locally on our computer inside this Docker file, which automates the entire setup process. So now let's talk about setting this up. So first thing that you should do is to set up the directories if you've not already done that in one of the previous lectures. Let's clear this up and go to our home directory. Make the directory with the name A2A in your home directory. Change to that directory and then check out the code over here. Once you do that, you'll see a folder with the name of A2A_samples. You can change to that folder. And again, when you list all the files inside that folder, you'll see all the different versions that we have. And this is the version that we are going to work with, which is version 6 Docker Vision Agent. Great. So you have the directory set up, the code checked out, and the version 6 available. And now you can change to the version 6 folder over here to work with it as shown in the demo previously. The next step is to download and install Docker. Let me show you how to do that. So let's search for Docker desktop download and click on the docker.com link, which is the official download website. And let's scroll down and you'll find this link to download Docker desktop. Let's hover on this button and you'll see the options over here. Please download it for your system. I'm going to download it for Mac, Apple, Silicon. Let's wait for a minute for this to get downloaded. All right, so I already have it downloaded from before, and once you get it downloaded, you'll have a DMG file which you can just double click and then drag the Docker application to the applications folder over here and leave it over there. So I already have this installed, and then I'm just going to open this from the applications folder. So you can go to the applications folder from here, look for Docker, and then double click to open this. So once you have this open, you can sign in. Otherwise, you can actually skip by clicking over here. And now you have your Docker desktop open, and in case you have some previous containers, you might see them over here. Now let's understand how to set up our Google Cloud environment. So we open a new tab and go to Google Cloud Platform. And here we have it. Okay, and let's click on sign in first. Let's click next. We enter our password. All right, so now we have signed into a Google account, and we can actually click on get started for free. All right, and to start for free with $300 free in credit, you need to click on start free, but you will need a particular payments profile. Okay, now since I'm recording a demo and it's not for an organization, I'll choose individual over here. I'll actually have to put in my details, the real details, true details over here, because it does require my legal name over here. So I'm going to do that and then click create. Now I've completed the payments profile and I added a credit card which was charged a very minimal amount for verification, and we're presented with this welcome screen. So a small disclaimer over here that please make sure that you read and understand all the things that you are entering and accepting as policies from Google, because this is a live account that can be used for hosting things. It can be charged amounts, right? And you are responsible for the creation and conduct of this account. So do give that proper attention and consideration before proceeding, right? Now over here we ask some very basic stuff like what best describes the organization needs. So let me just say it's a very small company, I guess a startup, right? And we click next. And what brought you to Google Cloud? Let's say learn more and explore. And then what are your interests? So let's choose web and mobile apps for now. And then what best describes your role, and you can put in whatever suits you. I'm going to put engineer developer over here and click done. Okay, and now as you see, you have the welcome page and you have some free credits to use over here which expire in around 3 months of time. Okay, so let's check out the project that we have over here. So Google has already created a project for us which is called the My First Project, and it has a specific ID over here. All right, so let's move further. Now we'll install the GCloud CLI, which is the command line interface for Google Cloud. So let's search install the Google Cloud CLI. All right, and we get this link. Let's click here. Okay, and here we are with all the instructions. So I'm using Mac OS and I'll choose this. So first, what we need to do is that we need to confirm whether we have a supported version of Python installed or not. All right, and let's do that. We'll open terminal, and here we have our terminal window, and then let's just follow the instructions from Google's page. So we first need to check whether we have Python 3 or not. So let's just check Python 3 dash v, and we have Python 3.1.2.2 installed, right? And in case you don't have this installed, what we can do is that we can install a Python version by going to Python releases for macOS. So let's look at that as well once, right? So it says the latest one is Python 3.1.3.1. So let me just try to install that over 3.12. So when you scroll down, you'll see all these files available. Now, since I'm on Mac OS, I can use this particular file over here just to confirm, what Mac OS version you are running. You can actually press Command space, and you can select about this Mac, right? So what I'm going to do is I'm going to click on this file and allow the downloads, right? And I'm going to wait for this to download. Once you have downloaded this installer for macOS, you can go to your downloads, click on this and open that particular package over here, and you'll be presented with the Python installer. So you can follow the instructions in the installer. I'm going to do that right now for myself. So now I click on install. Okay, so now this is going to install Python 3.13.1 for me. So for now I'm going to click close, and I'll move the installer to the bin. And now let me go to the terminal, and if I just do this again, I'll get the updated Python version, which is Python 3.13.1. So this way you can install Python if you don't already have it installed. And now we can continue with our Google Cloud command line interface setup. So let's go back to our browser and click on back to go back to Google Cloud, and let's go on to the next step. So the next step is to download one of the following, which is the package for Google Cloud CLI. All right. So what I'm going to do is I'm going to use the ARM64 Apple M1 Silicon because that's what my machine is. Let's click on this, and it says we want to allow downloads, and again we allow the download and wait for the download to complete. Okay, so once the download completes, let's go and select the downloaded tar file, and it should automatically expand. All right, and now we see that we have downloaded the Google Cloud SDK. It's expanded into a folder over here, and what we're going to do is we're going to move this to our development directory that we had built last time. So we'll go to development. Over here we press command enter to open new terminal, open a new tab, and let's just try dragging it right over here, and we have it dragged over here. So now all our stuff is well arranged inside the development directory. Okay, so now since we have the SDK downloaded, we can go on to the next steps, which is to actually install it. So let's copy this command from here to install the SDK, and let's paste it in our shell. And of course, we need to shift to the development directory and then paste this command. So this is going to install the Google command line interface for us, Google Cloud command line interface. And do you want to help improve Google? So let me choose no for now over here. Okay, and it gives me a set of components that it has installed. Apart from the components, it will also update your path variable and enable shell command completions. And it also asks for a RC file for any kind of settings that need to be put in that file. So I'll leave this blank to use the default one. I don't want to run the Python installer since I've already installed it. So I'll say no over there. Then I go back and start with the init command. So this is the init command for me, and let's just paste it over here. So this will ask us to actually log in to our Google account, and there that is. So you must sign in to continue. Would you like to sign in? So I'll say yes. So sign in using your account over here. So once you've signed in, it asks for permission. So I'm going to click continue over here. Okay, and now it says you're authenticated with Google command line interface. So I'll go back to the terminal, and it says pick a cloud project to use. So this is going to be the default project that it's going to use, and I'm going to use the first item. So I'm going to press 1 and enter that. So it set the current project now, and it seems all the init aspects have been completed. To run this agent, let's head to a terminal window, and first we are going to start Docker desktop. So search for the Docker application and click it to start it. Once it is started, you can actually minimize it and head back to the terminal. Now let's head to the directory where we have checked out the code. So I'll shift to the A2A samples directory, and then I'll change to the version 6 folder. The first step is to build the Docker image. So let's type docker build-t vision agent docker, which is the name or the tag that we're going to give to the image. And then we'll put the dot at the end for the build context. Let's press enter. Now this builds the Vision Agent Docker image. We are going to test this image out locally before we deploy it to Google's cloud platform. To run our A2A Vision Agent, we are going to use the docker run command. This docker command runs a container from the Vision Agent Docker image that we just built. The RM flag ensures the container is automatically removed after it stops. -p 10003:10003 maps the port 10003 of the container to the same port on the host, making the Vision Agent accessible externally. The -v flag mounts a local folder, which is the image samples which are AI generated that I just showed to you in the code repository, to the root image samples AI generated folder inside the Docker container. So whatever you put inside the image samples AI generated folder that was checked out from the code repository, that's going to be available inside the container inside /root/image samples AI generated. So this allows the container to access local image files. So let's run this by pressing enter. And now you can see that our A2A server and agent has started, and it's available on localhost 10003. So now let's open a new tab to send this a curl request. So I've pasted the curl command over here, and what this curl command does is that it sends a post request to the Vision Agent running locally on port 10003. The -d flag provides the request body, which follows the JSON RPC 2.0 format. It sends a task to the agent with the method tasks/send, passing in a session ID, a unique task ID, and a message with the role user. The message has a single part of type text, which asks the agent to describe the image, and the path that we provide is that of the container, which is available at /root and the image samples AI generated folder with the name of the file at the end. So this is basically the path that points to the folder mounted inside the Docker container, allowing the agent to access and analyze the image. So let's press enter now. Now this JSON response is sent back by the Vision Agent after processing the image analysis request. It confirms the task was successfully completed. That can be seen over here. And the history field shows the full exchange, the user's original message, which is over here, and the agent's response describing the particular image, which is over here. The agent identifies the image as a vintage beige computer setup with the monitor, keyboard, mouse evoking a retro 1980s to 1990s aesthetic. Great, we have tested this locally now, and now it's time to build this and push it to the Google Cloud platform. So let's clear the screen, and to push this to the Google Cloud platform, we're going to build a fresh image using the docker build command, targeting deployment on Google Cloud platform. So docker build is the basic command to build the Docker image. The platform space Linux / AMD64 ensures compatibility with Google Cloud's preferred architecture. No cache forces Docker to rebuild all layers from scratch, ensuring you get the latest state with no cached steps. The -t gcr.io / the AI language -prod / Vision Agent Docker. This sets the image name and tag. In this case, you're tagging it for Google's container registry under the project, the AI language -prod, which is what is the project that I'm using, and I'll walk through the setup to set up your own project. And we're using the image name Vision Agent Docker. The dot tells the Docker to look for the Dockerfile and build context in the current directory. So this will prepare the image for pushing to GCP's container registry. Let's press enter now. Now we are going to push our locally built Docker image to the Google Container Registry so it can be deployed on Google Cloud services like Google Cloud Run. So here's what we're going to do. We're going to run the docker push command. Docker push uploads a Docker image from your local system to a remote container registry. gcr.io / the AI language prod / Vision Agent Docker is the fully qualified image name, where gcr.io over here specifies that you're pushing to the Google Container Registry. The AI language -prod is our GCP project, and the Vision Agent Docker is the name and tag of our Docker image. So let's press enter now. Now we are going to deploy our Docker container to Google Cloud Run, making it accessible via public HTTPS endpoint. GCloud Run deploy Vision Agent Docker tells Google Cloud to deploy a new Cloud Run service named Vision Agent Docker. The image tag over here specifies the container image to be deployed, pulled from the Google Container Registry that we have just uploaded right now. Platform managed uses Google Cloud's fully managed environment, so we don't need to set up any server. Region Asia South 1 sets the region, in this case Mumbai in India, where the service will be deployed. Port 10003 tells Cloud Run that your container listens on port 10003, and allow unauthenticated makes the service publicly accessible without requiring authentication. So note that this is only recommended for demo and testing purposes. For production, you should enable some kind of authentication and disable this. So it's very important to mention this, that after you have tested this out, please delete the Cloud Run service. So this is no longer available at the URL that it will just give us. So this will not expose your agent to the public internet. But for this demo, we're just going to run this command to show how this can be done. So let's press enter. After this completes, we get this output which confirms that the Google Cloud Run deployment was successful. A new revision or version of the service was created, in this case Vision Agent Docker 00001-DD2. Routing traffic basically means over here that 100% of the incoming traffic is now being routed to this new version. Setting IAM policy is basically the identity and access management settings were applied, including whether unauthenticated users can access this service or not. The service URL over here is the public HTTPS endpoint where your agent is now live and can receive JSON RPC requests. Now, an important thing to note over here is that this is the direct HTTPS URL which will be forwarded to the port 10003 of our agent. So we don't need to specify a /10003 at the end. This is the URL that we can use in our curl command or from our front-end client to communicate with the agent running in Google Cloud Run. So now we're going to test out our agent on the Google Cloud platform, and we're going to use the curl command over here. This command sends a JSON RPC request to our Vision agent hosted at the public URL that was provided by Google Cloud Run. It asks the agent to describe the image at this particular path, and you note that the path over here is /app/agents, and this is the entire repository path for the sample images which have been AI generated, and we're providing the computer.png file. This is because all the images and the files inside the repository folder are copied inside the /app folder inside the Docker container. So we've already tested it with the curl command locally. The only difference now is that we have provided the URL, which is the one that was provided by Google Cloud Run, and the path of the image is the one that matches what's inside the container. Let's press enter. And now you can see that again the agent responds by describing this image. The state of the task is again completed. It provides us a timestamp over here. It provides us the full history with what the user sent as the message, which is the describe the image command or request, and then the response from the agent with the text part where there is the description that the agent provides. So guys, is this not completely amazing that now we have an A2A agent running on the Google Cloud platform using Google Cloud Run? It's a serverless environment. You can deploy any agent that you like over there, and you have a URL which you can actually call to ask the agent to do some work for you. In this case, we have used the agent to describe an image for us. So just to quickly tell you how to disable or delete your service, you can actually use the command GCloud container images list -tags with this particular tag that we've actually put before, and we press enter. This is going to list the tags with a particular digest ID over here. Then we use the command GCloud container images delete to delete this particular image by specifying this digest tag over here. And this is going to delete our image from the Google container registry. Alright, so this deletes the image, and now we also need to delete the service. For that, you can run this command GCloud run services list with the region specified and press enter. When you do that, you're going to get a list of services that are running. You choose the service that you want to delete. In our case, it is Vision Agent Docker. So we'll actually type GCloud run services delete Vision Agent Docker with the region specified and press enter. And now this is going to delete the running service for us. You can list the services again to check if it has been deleted or not, but this will help you delete the image and the running service so that you don't incur any charges for that, and it's not exposed to the public internet over that unauthenticated URL. We can now actually try to run the curl command again to try to ping the agent, and let's see if this works. Now we get the error that the requested URL was not found on this server, which tells us that our service has been deleted. Thank you for watching. I hope this was useful and you understood how to deploy your A2A agents using Docker to the Google Cloud platform. You can also use this to deploy it to other cloud platforms as well. Thanks again, and I will see you in the next video.